edge-rendered front ends with CDN functions, balancing performance, cost, and complexity. Hey, I'm the front-end developer. Today, we're unpacking edge-rendered front ends, generating HTML at the CDN edge to cut latency, improve first paint, and keep experiences snappy worldwide. What edge rendering really means. There are two patterns people blur together. One, edge compute SSR, where edge code fetches data and returns HTML. Two, CDN-assisted delivery, where HTML is pre-rendered and the CDN mostly caches and routes. We're focusing on edge compute SSR, dynamic HTML decisions near the user, without deploying your whole backend everywhere. Why teams move rendering to the edge? 3 wins drive adoption. Latency. Route and personalize by geo, locale, auth, or experiments closer to the user. Caching. Cache by safe request context so fewer pages are forced to be uncacheable. Resilience. Serve usable pages with stale while revalidate and smarter edge routing when origin systems slow down. The real trade-offs: performance, cost, complexity. Edge rendering isn't free performance. Performance risks include cold starts, compute limits, and losing gains if you add multiple origin calls. Cost shifts to per-invocation compute and expensive cache misses, plus multi-region observability. Complexity jumps, distributed debugging, 2 runtimes, and strict boundaries for security and secrets. A practical architecture. Edge shell plus origin data API. A pattern that works. The edge composes HTML and routing, while an origin API does data-heavy work. The edge reads safe context like URL and locale, calls a compact data endpoint, then renders HTML. Keep dependencies small, move DB access to origin, and cache data separately from HTML when you can. Here's Python-flavored pseudocode showing variant keys and conservative caching for authenticated users. Python. From urlib, parse import Erlang code. Def derive or variant, request. Locale equals request. Headers. Get, accept language, n. Split, com, ab equals request. Cookies. Get, ab b, control. Return, locale, locale, ab b, ab. Def handle, request. V equals derive or variant, request. Cache key equals f request, path, v, v. Cached equals cache get, cache key. If cached. Return cached. QS equals Erlang code, locale, v, ab, v. Data equals fetch, f, https://api.gexample.com/edge data request, path. Operational checklist. Decide before shipping. Make these choices explicit. Your cache key and what's safe to include, which routes truly need HTML personalization, where secrets live, what the fallback is when origin is slow, and how you trace a request across edge and origin. If you can't answer these, you'll still ship, just with confusion. Services and libraries that fit this model. CDN and edge options. Cloudflare workers and pages functions, Fastly compute, AWS CloudFront functions, and Lambda at edge, Vercel edge functions, and Netlify edge functions. Tools. Lightweight templating, fetch-based HTTP, open telemetry traces, and structured logging with sampling. Closing. A balanced recommendation. Edge rendering is a power tool. Start with one or two high-traffic routes, measure impact, then expand. Push HTML decisions closer to users, but keep data and complexity where you can control it. Thanks for watching, and I'll see you in the next build.